Oh, there you go. And I'd like to thank my colleague Megan Hendrick for work on a variety of different aspects of this project, and Jared Coopersmith as well at Ipsos. I was talking to John, he said he had 130 slides. I said, how are you going to get to my slides? It's only 35. He says, well, it's like motion picture. John, in the summer of last year, I preceded John, and today he precedes me. So he didn't interfere too much here. We've been working together for 25 years. So our work, I was saying, this is sort of my homage to him. Last time I was sort of attacking some of his ideas about agreement scales. This time I'm actually reinforcing his beliefs, or was he reinforcing mine? Anyway, so part of it here is many times we're interested in obtaining a sample to represent people and ideas that we're interested in as well. But oftentimes we have too many of one type of person, too few of another type of person. So, and it's the typical skews that you see. We oftentimes will assume that the people that we're missing are very much like the people who are there. So that's a basic assumption of weighting is that if you're going to weight up people or weight down people, you're basically weighting up people who to represent people who aren't there, right? And the people you have should represent them. But there's obviously fallacies there, and we have to sort of think about that a little bit more carefully. But if the people I'm just missing at random, then we might expect that weighting should reduce bias, right? If compared to unweighted data. This is going to look at a lot of different studies, including John's work and some of my work as well. But ultimately, we believe that weighting the data can lead us to some sort of paradise. And in terms of representation, it's a representation paradise. I have to keep reminding myself that I'm truly an experimental measurement methodologist, and yet I've been drawn into the field of weighting and sampling and do a lot of ABS study designs, et cetera. But, and have to always face the idea of how do we weight ourselves to truth. And we are faced with a couple questions, though. Is missing this at random assumption true for all samples? And will weighting show benefit for all samples in terms of reducing bias or reducing error? And people call it error in some cases and bias in other cases. But one of the things that we want to try to do is look at the differences among benchmarks that we might use to determine whether we have bias or error in our surveys. The benchmarks that we see out there can vary in terms of the population, their sampling frame, the extent of non-response, the measurement clarity. I think measurement is a critical issue in terms of comparing whether a survey is done online or by phone or in person. And that will oftentimes lead to mode effects, and then size of sample and how effective the weighting was. So there's a lot of things that will vary between the benchmarks we look at and reasons why you might actually get differences in benchmarks. And I show you an example of what we were faced with back in 2012 when I looked at a lot of benchmarks, and I talked to John about this. I said, I'm getting benchmarks for NHIS for having a cell phone at 88.6, and then NEANES at over 90%, 95%. And so you see these differences between never having smoked, between NHIS and BRFSS. You also see like obesity there between NHANES, BRFSS, and NHIS. Substantial differences between what we would use as benchmark measures and how do we determine those. And in talking with John, he says, well, I tend to rely upon NHIS because in terms of bias, BRFSS has a possibility for social desirability, which may be reflected in its lowest obesity score. NHANES may actually have a higher obesity score because you're actually measuring them and giving them physical weight and height. And so, in selection of benchmarks, and that's what we always are faced with, is how do we compare it, our survey data, with these benchmarks when the benchmarks themselves disagree, but having said that, we make our decisions and we go with it. And so this is showing the Jaeger and Krasnick study that was published in 2011, but actually reflected a 2004 study, which I helped them with when I was one of the opt-in samples over there to the right, Harris Interactive, and he's not really told me which one it was, and a knowledge panel and a phone survey were the probability-based samples, right? So I was on the dark side, he was in the light side, making these comparisons, and he showed that probability-based samples up to 2004, I thought we were doing pretty well predicting elections. But when you look across a number of different benchmarks, the opt-in samples really didn't show as low bias as the probability-based samples. And I parsed his study out a little bit. I pulled them out so you could see where weighting makes a difference and where weighting actually improved the estimates. And so I show you, and this was from the article, and so I pulled it from the article, but to show it in a colorful way rather than numeric way. You see that the green circles there reflect where you've had at least a significant reduction of bias when you weighted the data. So 2 opt-in samples benefited from weighting, and both probability samples benefit from weighting. And then you also see that the others really didn't benefit from weighting. The other opt-in samples did not benefit from weighting. This is another study where I was responsible for developing the survey and fielding it with 17 different opt-in providers and doing a phone survey, the FOQ 2 effort by Advertising Research Foundation in 2013. These 17 different sample providers were providing 3,000 cases each. Each was providing 1,000 cases due to different quota structures. So I was interested in the quota issues and how strong quotas versus weak quotas could affect your biases as well. But each provider essentially provided 3,000 cases along with a phone survey. So we had 24 benchmarks that you see, some health-related, a variety of measures there. And this is the average deviation from benchmarks. So again, there's a couple different ways of measuring it, and John does root mean square later. The earlier one was using average deviation in general. There's a discussion there. But here we see the weighted versus unweighted versions, and always you'll see that the probability is to the left, and the blue is always, or the blue or purple here, it looks like, is always the weighted values. So you'll see the telephone survey there, the probability-based survey, when weighted, is one of the best estimates in terms of lowest bias. Unweighted, though, it was not so good compared to the opt-in samples. Opt-in samples were unweighted actually seemed to be better, but weighting helped probability. So it was, as we see here, probability was helped by weighting, and then 2 of the opt-in samples out of 17. And when we look here is that the red circles indicate that 5 of the opt-in providers added bias by being weighted. So weighting did not reduce the bias, it actually increased their error or their deviance from the benchmarks. And then we see another 7 providers in which weighting did not affect bias one way or the other, up or down. What does weighting do for opt-in samples? Well, maybe it helps and maybe it hurts, or maybe it doesn't do anything. Now this is using the McInnes and Krosnick study that he also mentioned, and the 2 blended samples are in the middle, but I parsed out just the probability and the non-probability samples alone, not the blended. So you see where weighting actually helped was the probability sample again, and only 1 of the opt-in samples were helped, and it was the worst opt-in sample that was helped by weighting. The other 5 in this case, the other 5 opt-in providers did not improve bias or reduce bias due to weighting. So that's that study. Now this is the first study that's somewhat new. We had back in 2020, we did a study with Knowledge Panel, opt-in sample 1, opt-in sample 2, opt-in sample 1. Did not have any quotas, which was a little interesting to try to contact my sampling group and say, I want opt-in sample, don't impose any quotas, just give me 3,000. Easy enough, went over 3,200. And then opt-in sample 2, I said, okay, give me a sample here that has quotas on it, age, gender, education, region. You just make sure it's a balanced sample coming into the survey. Okay, so there's a difference there. And they couldn't do it quite as easily because I ended up with 2,600, right? So we had 22 benchmarks here, political, health, secondary demographics as well. And this just shows again, the knowledge panel with the unweighted versus weighted. weighting helped probability based. And in this case, both the opt-in samples were helped. The opt-in with no quotas actually was more biased to begin with than the opt-in with quotas. And it was actually more biased even after weighting. So it's even after weighting, it doesn't necessarily, it doesn't address the issues of reducing bias fully. And this study is a more focused study in Georgia in 2020. So we were looking at it as a potentially interesting technology too, to look at what was called redirected inbound telephone call sampling, where they would actually sample inbound calls as they're about to hang up to see if they could do a survey, and then would send them an IVR technique. And basically we compared knowledge panel opt-in and RICS, and the field period again was about a month. About 500 in knowledge panel, and you see about 1,200, 1,300 in the other panels. And the benchmarks, we had 7 benchmarks there. We see the knowledge panel benefited from weighting, a very small sample, and it was a skewed sample for state. But then opt-in and RICS were both biased, and they were also, weighting did not help them. It actually went the wrong direction. So discussion, in conclusion, every case we examined, normal demographic weighting significantly reduced bias in probability-based samples. However, for non-probability-based samples, weighting can improve or diminish the effects or the bias that you find. In addition to non-probability samples having higher overall bias, this bias does not appear to be a result of cases missing at random, but is most likely due to processes that are not corrected by normal demographic weighting. Thank you.